Asthma is a prevalent obstructive airway disease characterized by inflammation of the respiratory system. Patients with asthma are prone to experience symptoms such as wheezing, chest tightening, cough, and even suffer exacerbations. The severity of asthma symptoms associated with these conditions can be exacerbated through the lungs' exposure to viruses, allergens, and bacteria. When a virus infects a cell, these infected epithelial cells can release cytokines and inflammatory mediators, including thymic stromal lymphopoietin, TSLP. TSLP is thought to induce the airway inflammatory response through its ability to modulate the activity of various immune cells, including dendritic cells, mast cells, and lymphocytes. Binding of TSLP to its receptor on dendritic cells triggers the release of mediators important for activation. Activated dendritic cells then initiate other cells' involvement in the inflammatory response. Here, the dendritic cell interacts with an undifferentiated T cell and activates it to form into a Th2 cell. Th2 cells then release cytokines, which include interleukin-5 and interleukin-13, to further the inflammatory response. Interleukin-5 is a signaling molecule that is released by Th2 lymphocytes. Interleukin-5 can control the differentiation, activation, and survival of eosinophils. It does this through interaction with the interleukin-5 receptor alpha found on cells including eosinophils. When activated by interleukin-5, eosinophils are thought to play a key role in inflammation in the airways. Eosinophils release cytotoxic granule proteins and pro-inflammatory mediators and make the airways more hyper-responsive to stimuli, such as allergens and pathogens. Interleukin-13 is another cytokine released by various immune cells, including Th2. Interleukin-13 binds to cognate receptors on neighboring inflammatory cells, including interleukin-13 receptor alpha-1, leading to heterodimer formation with interleukin-4 receptor alpha, which triggers a signaling cascade that induces an inflammatory response. This effect is thought to promote the contraction of smooth muscle and the secretion of mucus, as well as make the airways more hyper-responsive, leading to the obstruction of the airways in asthma. These complex signaling pathways and molecules highlight some of the key targets that are currently being explored by Astrazeneca in the treatment of asthma.